6 questions have been given from the section Hyperbola in the JEE Main examination in the January 2024 session. We will now discuss the first 3 questions out of those 6 questions that have appeared in this session. This question has appeared in the JEE Main exam held on 27th January 2024 in the second shift. Let E1 be the eccentricity of the hyperbola x squared by 16 minus y squared by 9 is equal to 1. We are given E1 is the eccentricity of this hyperbola, and E2 be the eccentricity of the ellipse x squared by a squared plus y squared by b squared is equal to 1, where a greater than b. It is further given E2 is the eccentricity of this ellipse, and this ellipse passes through the foci of the above hyperbola. This ellipse passes through the foci of the above hyperbola. It is given to you if E1 E2 is equal to 1, then the length of the chord of the ellipse parallel to x-axis and passing through 0, 2 is. We are given E1 E2 is equal to 1. Required to find the length of the chord of the ellipse parallel to x-axis and passing through 0, 2. We are given 4 options. We will now discuss the solution of the problem in detail. We are given E1 is the eccentricity of the hyperbola denoted by h, given by x squared by 16 minus y squared by 9 is equal to 1. Here you have to think a square is equal to 16, that is a is equal to 4, b square is equal to 9, that b is equal to 3 for this hyperbola. Right, this is our hyperbola. Right. Now we want to, what will be the E1? E1 will be equal to under the square root of 1 plus b square by a square. That is equal to under the square root of 1 plus b square, that is 9, by a square, that is 16. And simplifying, we will get it is equal to 5 by 4. Right, it is greater than 1. Okay. Now, the foci of this hyperbola are plus or minus AE1 comma 0, that is equal to plus or minus A is 4 times E1 5 by 4 comma 0, that is the foci are plus or minus 5 comma 0. So these are the foci. This is F1 5 comma 0, F2 minus 5 comma 0. Right. Given E2 is the eccentricity of this ellipse, E is equal to E given by x square by a square plus y square by b square is equal to 1, where a greater than b, and it is further given E1 E2 is equal to 1. We will use this E1 E2 is equal to 1, and we know E1 is equal to 5 by 4, we find E2. So E2 is equal to 1 by E1, that is equal to E2 is equal to 4 by 5, right, less than 1. It's okay. Given this ellipse E passes through plus or minus 5 comma 0 of the hyperbola. So substitute in the equation of the ellipse x is equal to 5, y is equal to 0. Great. If you substitute, it will be 5 square, that is 25 by a square, and y is 0, so is equal to 1. So from this you will get a square is equal to 25 and a is equal to 5. Okay, no problem. We have E2 square, that is the square of the eccentricity of the ellipse is equal to or 1 minus b square by a square. And E2 is 4 by 5. So 4 by 5 square is equal to 1 minus b square by a square is 25. We do not know b, that is why we have kept it like that. So solving for b square, we will get b square is equal to 9. Thus we got the knowledge of the ellipse completely now. So thus the ellipse is given by x square by a square, that is 25, plus y square by 9 is equal to 1. That's our ellipse. Let's look at the picture diagram. So passing through the foci, and this is the ellipse. Agreed. Now we continue in the next slide. Now we have the ellipse x square by 25 plus y square by 9 is equal to 1. What is to be found? Required to find the length of the chord of this ellipse parallel to x-axis passing through 0, 2. So this is our ellipse. This is the point 0, 2 on the y-axis, and required to find the length of the chord of E parallel to x-axis. This is parallel to x-axis passing through 0, 2. So this chord length you want. To find this chord length, we have to find out what are the end points of it, the coordinates of the end points. If you know, you can find out the length of such a chord. So in this, put y is equal to 2 in the equation of the ellipse. So y is equal to 2 you substitute, then you will get x square by 25 plus 2 square by 9 is equal to 1. And from that, x square by 25 is equal to 5 by 9. And you will get x is equal to plus or minus 5 root 5 by 3. So the end points of the chord of the ellipse E parallel to x-axis and passing through the point 0, 2 are, let's say one end point is A with 5 root 5 by 3, 2, B with minus 5 root 5 by 3, 2. This is your A, this is your B. Well, what is the length of the chord? The length of the chord is the difference of, modulus of the difference of the abscissa, that is the x coordinates. So the length of this chord AB of the ellipse E is 5 root 5 minus of minus 5 root 5 by 3, that is 10 root 5 by 3. So let's look at our options. Our answer 10 root 5 by 3 appears against option 4. Therefore, the answer to this question is option 4. That is the detailed discussion of the solution of the given problem. I am sure that you have understood the solution of this one. Let's move to the next question. This question has appeared in the JEE Main exam held on 30th January 2024 in the first shift. The given question is, let the lattice rectum of the hyperbola x square by 9 minus y square by b square is equal to 1 subtend an angle of pi by 3 at the center of the hyperbola. So we have the hyperbola. The lattice rectum of this hyperbola subtend an angle of pi by 3 at the center of this hyperbola. If b square is equal to L by m in brackets 1 plus root of n, where L and m are co-prime numbers, then L square plus m square plus n square is equal to. We are given b square is equal to L by m into 1 plus root n, where L and m are relatively prime, then required to find the value of L square plus m square plus n square. Let's now discuss the solution of this problem in detail. We have the hyperbola h given by x square by 9 minus y square by b square is equal to 1. So here a square is 9. Right. So that is our hyperbola h, and the center of that is 0, 0. The vertices are a prime, and the foci are given by s and s prime, which are given by plus or minus ae, 0. Right. Given the lattice rectum L of h subtends an angle pi by 3 at the center of h. Agreed. The lattice rectum is here. This is the lattice rectum L. And it is given that this lattice rectum subtends an angle pi by 3 at the center of the hyperbola. So it is subtending an angle of pi by 3. Pi by 3. Right. Right. What is L? L is 2b square by a. What is the length of the lattice rectum? 2b square by a, the whole one. Suppose we talk about only a half of it. Then the angle will be pi by 6 with the x-axis. Pi by 6. So we take tan of pi by 6 is equal to, tan of pi by 6 is half of the length L by 2. L by 2 is 2b square by a by 2. That is b square by a by this distance s 0 to O origin to s. That is a. So now what we are talking about is this one. So this is your L by 2. L by 2. And this angle is pi by 6. That is pi by 3 by 2. The half of pi by 3, pi by 6. Now tan pi by 6 is equal to L by 2 by AE. L by 2 is b square by a, where L is 2b square by a. Agreed. So that is what we have. Now that will be equal to b square by AE is b square by a square e is equal to tan pi by 6 is 1 by root 3. From this we get E is equal to b square root 3 by 9. E square will be 3b to the power of 4 by 81. Now, what is E square? The eccentricity square. That is 1 plus b square by a square. B square is b square, a square is 9. 1 plus b square by 9 is equal to b to the power of 4 by 27. Take the LCM, then you will get b to the power of 4 is equal to 3b square plus 27. Now, what is to be obtained? You obtain b square and look at the form that is given in the question. So solve for b square. Think of that this is a quadratic in b square. So you will get b square will be obtained using this formula, and b square value will be 3 by 2 into 1 plus square root of 13. And it is given to be L by m into 1 plus under the square root of n. Comparing the corresponding terms, you will get L is equal to m, L is equal to 3, m is equal to 2, 3 and 2 are relatively prime, it's okay. And root n is root 13, that is n is equal to 13. So this will imply L is equal to 3, m is equal to 2, they are relatively prime, the GCD is 1, n is equal to 13. What is to be obtained? To compute now L square plus m square plus n square. So L square is 3 square, m square is 2 square, plus n square is 13 square. Added, you will get 182. Therefore, the answer to this question is 182. That is the detailed discussion of the solution of the given problem. It is definitely an easy question. I am sure that you have understood the solution of this problem, and we will move to the next question. This question has appeared in the JEE Main exam held on 30th January 2024 in the second shift. The given question is, let P be a point on the hyperbola h given by x square by 9 minus y square by 4 is equal to 1 in the first quadrant. So, you are given a hyperbola h and P is a point on this hyperbola in the first quadrant, such that the area of the triangle formed by P and the two foci of h is 2 multiplied by under the square root of 13. So, it is given the area of the triangle formed by this point P on the hyperbola and the two foci of this hyperbola is given to be 2 times under the square root of 13. Then the square of the distance of P from the origin is, so you have to obtain the square of the distance of this point P from the origin, and we are given 4 options. Let's now discuss the solution of the problem in detail. Let P with coordinates x1, y1 be a point on the hyperbola h given by x square by 9 minus y square by 4 is equal to 1 in the first quadrant. This is the hyperbola and we are in the first quadrant. The point P is here. Right. P is a point with coordinates x1, y1 of this hyperbola in the first quadrant. Now, to find, what is to be found? The square of the distance of P, whose coordinates are x1, y1 from the origin. What is the distance? x1 square plus y1 square. This is to be found. So that means you have to find what are the coordinates of P. Then find x1 square plus y1 square. So, and let's look at the given data. Given, what is given? The area of the triangle formed by P and the two foci of H, that is S and S prime. What is the triangle? P, S, S prime. That triangle, the area. It is given to be 2 under the square root of 13. Now, this is now written 1 by 2 into the base S, S prime into the height. The height is y1. So, this is the triangle. Agree. And area is 1 by 2 half into base S to S prime into the height y1. This is the y1. The height is y1. Right. What is SS1? So, this is AE. This side is AE. 2AE. So, the distance between the two foci is 2 times AE. And that's 1 by 2 into 2 times AE into y1. y1 is equal to 2 multiplied by under the square root of 13. 1 by 2 cancels. A is, A square is 9, A is 3. So 3E multiplied by y1 is equal to 2 into under the square root of 13. Call this as the equation 1. And in this, E you can find out. From that you can find out y1. From y1 you can find out x1. From that you can find out x1 square plus y1 square. So for this hyperbola, h, x square by 9 minus y square by 4 is equal to 1. A square is equal to 9. B square is equal to 4. A is equal to 3. B is equal to 2. A greater than B. So, when A greater than B, E square for the hyperbola is 1 plus B square by A square. So, 1 plus B square is 4 by A square is 9. That is equal to 13 by 9. And E, the eccentricity will be under square root of 13 by 3. So, go back to the equation 1, substitute for E and obtain y1. So, from 1 you will get 3 into E root 3 by 3 into y1 is equal to 2 times root 3. 3 cancels and root 3 cancels, and y1 will be equal to 2. When you get the y1 is equal to 2, you can also use the fact that p x1 y1 lies on this hyperbola and get x1. That we will do in the next slide. We have y1 is equal to 2. To find the square of the distance of the point P x1 y1 from the origin, and that will be x1 square plus y1 square, where P x1 y1 is a point on the hyperbola. Now P x1 y1 is a point on the hyperbola h given by x square by 9 minus y square by 4 is equal to 1. Substitute y1 is equal to 2 and solve for x1 square. So you will get x1 square by 9 minus y1 square 4 by 4 is equal to 1. That will give you x1 square by 9 is equal to 1 plus 1, 2. That is x1 square is equal to 18. Thus we got x1 square is equal to 18 and y1 is 2, y1 square is 4. So the square of the distance of the point P x1 y1, which lies on the hyperbola h from the origin, is equal to x1 square plus y1 square. X1 square is 18, y1 square is 2 square 4, that is equal to 22. So let's look at our options. Our answer 22 appears against option 1. Therefore, the answer to this question is option 1. That is the detailed discussion of this problem. And this is definitely an easy question. Agreed. And in this discussion, we have taken the first 3 questions that have appeared in the JEE Main January 2024 session from the topic hyperbola. I am sure that you have understood the solutions of all these 3 questions, and I wish you all the best. Thank you.